to say that solution was incorrect. Okay, in the gaseous state, chlorine exists as a diatomic molecule Cl2. And then they give us the molecular mass. Calculate the number of moles of chlorine present in 100 grams of chlorine gas. So let's do that first. So our mass of chlorine is 100 grams. We know the molar mass of chlorine was given in the question as 70.9 grams per mole. Okay, so we are going to be using the following equation, where number of moles is equal to mass over molar mass. So it'll be 100 grams divided by 70.9 grams per mole. And if you forget which one goes on top, like the mass or the molar mass, this is when you can double check your units. So your grams should cancel out, and then your moles goes from the bottom to the top. And then this gives us a value of 1.41 moles. That's part A. Part B. How many moles of PCl5 can be produced from 55 grams of chlorine and excess P4? So it looks like they answered it already, but I'll still write down the steps. And then the actual question, what mass of PCl5 will be produced from the given masses of both reactants? Okay, so before I do any calculations, first I'm just going to write down the reaction equation. So we have excess P4 reacting with Cl2, and we know our product is PCl5. Okay, so this is the general reaction, but before I do any calculations, I just want to make sure that everything is balanced. So I have 4 phosphorus on this end, so I'm going to put a coefficient of 4 here. So this changes the number of chlorine atoms we have. So now we have 20 chlorine atoms. So I'm going to put a 10 on this side, just to make everything balanced. Okay, so this is our final balanced reaction. How many moles of PCl5 can be produced from 55 grams of chlorine? So since we have excess P4, I'm going to calculate the number of moles of chlorine, since it is our limiting reagent. So just by using the same equation as up there, the number of moles is equal to mass, which is 55, over molar mass, which is 70.9 grams per mole. Okay, so then if I calculate the number of moles of this, you get 0.78 moles of Cl2. So in order to calculate the number of moles of product, we are going to use molar ratios. So I want to get the number of moles for PCl5, so I'm going to put that on the top with its coefficient of 4. And at the bottom, the coefficient for chlorine was 10. So I'm putting 10 moles of Cl2. And if you get confused about which one is at the top and which one's at the bottom, always make sure you look at your units. So your moles of chlorine should cancel out, and the moles that you're looking for remains. So in our case, the moles of PCl5 will be on top. And then if we do this math, we end up with 0.310 moles of PCl5. So this is the same answer that the person asking the question got. But we want to look for the mass. And we can do that using the number of moles times the molar mass. So for PCl5, we calculated the number of moles to be 0.31 moles. And then the molar mass of PCl5 is 208.24 grams per mole. So when we multiply these two values together, we get 64.6 grams as our final answer. So let's check out. We did it to 3 significant figures, appropriate units. This is the answer of our junior tutor, which is sideways, but just by reading it, I can see they got the same answer as me. This solution is correct. And on to question